Now for problem C, beautiful XOR. So for this problem, we are given A and B, and we are required to convert A to B. How? By choosing any number from 0 to A, and be sure the current value, not the initial value, because A will change. You should apply this rule on the latest version of it, not the initial one. Anyway, and then XOR A with this X you have chosen, and continue doing that until you become B. So for this problem, let's try to make some examples. 1 0 1 0 1 1 1. This is A, this is B. First thing, before trying to answer the question, let's try to see, can we do that by any means? Let's try to see. We can say we wanna XOR A with this number, so they can be the same, right? And by the way, if someone don't understand XOR and interested in like learning them in any way, we can make a playlist speaking about bitwise operations and bitmask and these things. So just comment below so I can know. Anyway, now for this one, we can just if we literally just said for A to be XORed with this number, we will literally become exactly B, right? No, not only exactly B. We should also add one here so we can remove this. So this will remove this. This will let this one be 1. This we want to leave this as it is, so let it be 0. I want a 0 to be 1, so I put 1, and so this number is ordered this. But there's something. Is this number not something? We are trying to do two things, right? I'm trying to remove things that A has and B doesn't have, and I'm trying to add the things that B has and A doesn't have, right? So now let's think about two things. We want to add, let's say A has, B not, B has, A not. For B has, A not, can we always guarantee that there is an answer? No. Why? Because B can have something here. For A, it's impossible to get this one. Why? Because A is bounded by this. It's getting its values from these ones, so it can only play with its own ones, right? So we should make a condition. This is the -1 case. This is the invalid case, which is formally if the MSP in B is higher than the MSP of A, then the answer is invalid. A can't get this index. But for A has and B doesn't have, for this one, we will just remove it. And of course, we will have it. We can have it. We have it because X is already bounded by A, so we already have it. So we can remove anything here, but for this one, we are bounded by the MSB of A. Okay? So the first to check is the condition. If the MSB of B is higher than A, if the MSB of A, then -1 case, or I'm not sure, yeah, -1. Okay? So this is the invalid case. What about the valid case? Can we do it quickly? Note something. For this one, why we did it, we were not able to do it quickly, because this number is higher than this number, right? And here we are not trying to minimize the number of operations we'll be doing. So let's try to just do it in any way. And by the way, anyway here doesn't mean like brute force. No, I just mean like think comfortably. Because as you see, these operations are just XOR with this, XOR with this, XOR with this. So just constant number like 3, 2, 1, something like that. So let's see. Can we have, I want to make A, as I said, A has access to all of these bits. It can be anything in these bits. So why not, this is my solution for it. Why not letting it be as big as we can? For example, something like that. Why? I'm speaking about this A, by the way. Why? Because if I let it be like that, I can let it be with any, I can mask it with anything. For example, I want it to be 1 0 1 1. So I'll just XOR with the complementary of this, which is something like this, 0 1 0 0, right? So if I let A be something like that, it's easy to be anything from 0 to this number. Okay? So how to let it be something like that? To let it be something like that, I'll just be filling these things. Can I fill these things always? Yes. Why? Because I have the MSP here. So any zeros here, if I come like I made all of them in just one place, for example, here to be 0, 1, 0, 1, it will be always something less than the MSP. So I'll just get the complementary for A to let it be all ones. And once I do that, I'll be able to bitwise with the complementary of B. And complementary here is just a term that I just that I just made, which is just like the thing that complemented, like XOR with it will be this. Anyway, so let's try to see an example of what we are trying to do. 1, 0, 1, 0. We want it to be something like that. This is A, this is B. First thing, I said we want A to be all of things like that. So I'll just be XORing A with 0, 1, 0, 1. So A will become 1, 1, 1, 1. And then we want this to be 0, 1, 1, 0, right? So I'll just see what, like, I want to now XOR A with something that let it be like that. Like, so we can say I want A to be B, but what is the thing that if I XOR the A with, it will become B? So let's say uh, A XOR with something, let's call it X, becoming B. If I found this X, then I found the answer, right? What is this thing? This is XOR, right? So we can rewrite the equation as X is exactly equal to A XOR with B, right? And of course, we are higher than this X, so we can do it because of the condition we said. So that's the answer exactly. So I'll just show you the code for this problem C. So first thing, I'm getting the MSP. If the MSP of B is higher than MSP of A, so I'm just printing -1. Otherwise, what is this? This is just the mask, which is like all ones. If you don't understand it, it's just, for example, if I got the MSP to be something like that, for example, for A, it looks like that, right? So MSP is something like that. But I want all ones, like want 1, 1, 1, 1, right? So I can just say that this number is exactly 1, 1, 0, 0, 0, 0, multiplying this by 2, multiplying this number by 2. This is in binary, by the way. So multiplying by 2 will give me this in binary, 1, 0, 0, 0, 0, 2. And if I set for this number to be -1, it will give me this number in binary also. So that's why I multiplied by 2 and said -1 to make the complete thing. So the first thing, comp, which is just how I can let A, this is A, how can I let A to be all ones? It's the same thing. I want A to be all ones, XOR with something to be all ones, let's call it all ones. Okay, so X is just A, XOR with all ones, right? So that's why I made A with all ones, but I called it all ones here, I called it mask. Okay, which is all ones. Anyway, so that's comp, which will make it be all ones. And then this is the equation I explained earlier, which is I have A XOR with X to be B. So X is just A XOR with B. But I wrote here mask, not A, because A is now became the mask, which is all ones after this operation. So it's always constant in my way. So 2, and then printing this array. So that's it for problem C. I know it's it's really the longest explanation I made for any problem till now. But yeah, I think if I said something less than this, you may not understand. So if you still didn't understand, repeat the video. If you still didn't understand, please comment below, and I'll try to make another video for it. So this is for problem C. See you in problem D.